Hello everyone, my name is Ricardo Castro and I'm the lead site reliability engineer at Anova, a company that provides services in the industrial IoT space. And today we're going to talk about how to approach SLOs from scratch. So how are we going to do this? So we're going to start by defining what reliability means in our context. We'll then go through a series of concepts that will allow us to better understand what SLOs are. And then we'll end by talking a little bit about why all of this is important. So let's start by defining what reliability means. So if we go to the Cambridge Dictionary, we can see that the Cambridge Dictionary roughly defines something as being reliable if it's able to be trusted or believed to be doing what it's supposed to be doing. So it's a little bit convoluted. So I prefer the definition from Alex in his book, Implementing Service Level Objectives, where he essentially defines reliability for a service in the point of view of a user. So basically, he defines reliability that a service is reliable if it is doing what its users need it to do. So it's sometimes difficult when we start talking about SLOs because there's a lot going on, not just SLOs in particular. There are a bunch of concepts that come bundled with SLOs, and it's usually hard for teams to actually go from their usual way of measuring stuff and seeing if systems are reliable, going to SLOs because there are a lot of things going on. So we're going to start simple. So the first thing that we are going to do is say, okay, now that I know that reliability should be defined by the expectance of my users for my service, how do I do that? So the first thing and the most simple thing that we need is something that measures our systems. So we're going to start with something very familiar to all of us, which is a metric. So a metric is essentially a measurement about something. So if we want to know in the point of view of our users if the system is being reliable, we need to measure it somehow. So nothing better than a metric to actually do that. So here we have a few examples of what a metric could be. So the examples that we're seeing here are things like the amount of memory that the server is using, and we can measure that in percentage. The time it takes for an HTTP request to be fulfilled, and we can measure that in milliseconds. The number of HTTP response errors that a service responds with, and that could be a natural number. Or we can have a metric that says how old a message arriving from Kafka is. So now that we know that we can measure things with metrics, when we want to actually assess the reliability of a system from the point of view of a user, we need to find metrics that actually reflect the experience of a user. But now we have metrics, right? So we have a measurement. So we need a way that actually tells us if that metric is good or not. And that's where SLIs come into place. So SLIs are nothing more than a way for us to say if an event is good or bad. And of course, meaning that it's good or bad is highly dependent on our context. So what is a good event? So we need a way to achieve a binary state, even if the metric itself doesn't allow us to do that. So here are a few examples of how we can achieve that based on our previous examples for metrics. So we can define an SLI and say that an event is good if a request is responded within 200 milliseconds. Another example is that we can say that a request is good if it's not responded with a 500 code. And we can say that the message is good if it's not older than 5 minutes. So essentially, an SLI is a quality that we attach to a metric to say that if that metric is good or bad. So we take a measurement, we look at that measurement and we say, okay, this measurement is good or not. And that's all well and good, but we want an holistic approach to actually say that our system is being reliable or not. So we have metrics, we have SLIs, we're going to progress to our next concept. And is the concept that this whole presentation is based upon, which is SLOs. So SLOs build on metrics and SLIs, and it essentially means how many times an SLI needs to be achieved so that our users are happy with our service. And that needs to be measured within an interval. So here we have a few examples of what an SLO could be. So here we are saying that we have that 99% of requests to a service need to be responded within 200 milliseconds within a 30-day period. If we achieve this, we're within our SLO. We can also say that 95% of requests to a service need to be responded with a code different from 500 within a 7-day period. And we can also say that 99.99, or the famous 4 nines, of messages must be not older than 5 minutes within a 24-hour period. So the key takeaway here for SLOs is that we start by measuring something by using metrics. With SLIs, we say that for each of those metrics, if that metric is good or not, of course, within our context. And an SLO is essentially how many times an SLI needs to be true for us to actually be sure that our users are happy with our system. On top of SLOs, we have a few other concepts. They usually come bundled in, but need to be told in separate. So if we define an SLO by how many times an SLI needs to be achieved for users to be happy, we have a sister concept which is known as the error budget. And the error budget is nothing more than what is left from an SLO. So it's effectively the percentage of reliability left. So, for example, if we defined in the previous example an SLO of 99%, it means that we can tolerate 1% of unreliability. Error budgets help us make the operability process, for example, incident response, to track and appropriate to the budget available for the service being provided. And at last, our last concept, which is probably the concept that we know the best, is the concept of an SLA. And an SLA is nothing more than an SLO that has some kind of penalty attached. So it's usually a commitment between a service provider and a client, a business to business, an individual to business, and so forth. So the idea for SLIs, and because why we know them a lot, is because they're usually present in all kinds of commercial transactions. So let's just see a few examples to illustrate this. So here we are stating that 95% of requests to a service need to be responded within 200 milliseconds within a 30-day period. If that doesn't happen, the client will get a 30% discount on his bill. Another example is saying that 90% of requests need to be responded with a code different from 500 within a 7-day period. If that doesn't happen, that means that the client will get 50% of its money back. And lastly, we can say that 99% of messages arriving at a Kafka cluster must not be older than 5 minutes in a 25-hour period. If not, we're going to be fined 100,000 euros. A common approach is to use SLOs that are tighter than SLAs. And that means that if an SLO is broken, we still have some window to actually fix before breaking the SLI. So why is all of this important? It's important for several reasons. For starters, contrasting this to the traditional way of measuring reliability for systems, we now are defining reliability in the point of view of the user. So instead of using things like, oh, my CPU went above 80%, so I need to do something, we are actually trying to measure user satisfaction and only assessing that reliability based on that. That means that we can reduce our alert fatigue and actually trigger alerts that are actually reflecting the impact that our systems is having on users. It also allows us to create a shared language to talk about reliability. So there's no more this team defines reliability one way, that team defines reliability another way. We have all a common and shared vocabulary to talk about reliability and to actually know if our systems are actually being reliable or not. And because we are measuring reliability on the point of view of user, reliability actually ties directly to business goals. So it is our users that actually pay for the services that we provide or the products that we develop. So if we are measuring directly user satisfaction, we can be better assured that our users are satisfied and will keep buying our services and products. And it's also important because it facilitates prioritization. So now we have an analytical way to actually to measure reliability. So it makes easier to make decisions if we can take more risks, if we can deploy more often, if we can actually deploy that risky feature that we have. So these are just a few topics that actually make it very important that we have a way like SLOs to actually measure reliability. And this is all from my part. I hope this gives you a good overview of how we can go from having metrics to having an SLO approach and why all these concepts are very important. Thank you very much.